we're going to start with the machine learning process. So this is actually an introduction session to the complete world of machine learning. So the slide number 1 is actually talking about what is called as a process, right? What do you mean by process? This is the complete process of learning the machine learning part. Now, when I say machine learning, consider an example, right? I'll always try to discuss and elaborate the concepts with the help of, right, certain examples. Okay, so considering that, now you see, right, there is actually a construction process that is actually happening over here, right? So there are 4 different steps we have written with the number 1, number 2, 3, and 4. And as you move along with these codes, starting from 1, 2, 3, 4, etc., you can see the pictorial representation is being changed, right? The construction of maybe a house or a building, right? You can see improvement in that. So what is the step number 1? Leave the machine learning part. You look at the construction, right? You need to build from scratch, right? From the lowest level, right? You will first decide what is the shape, right, of the building. According to that, right? You start the construction. So equivalent of that when it comes to the ML case, right? When it comes to the machine learning, right? So this is going to be the mathematics and the programming part, right? So mathematics basically refers to, right, the one very important thing, that is a probability, right? What are the major aspects of mathematics that we are going to use? We must use, we have to use, because there is no other option. The whole process depends upon 3 components. One is the probability. The second thing is the statistics. And the third part is linear algebra, right? So as of, according to my knowledge, all the 3 have been covered in the engineering mathematics part. Those who have gone through that, those subjects, right? The graduate level mathematics, which we say, right? So after +2, you enter into any field, right? Where there you study the maths. So specifically for engineering students, it is engineering mathematics, right? So in one of the 4 engineering mathematics subjects, you will be definitely studying these 3 for sure, right? So there will be probability, at least one chapter, 2 chapters, then 1 or 2 more chapters about the statistics, and one more thing that is about linear algebra, right? So mathematics is needed. Again, we are not touching that because it's a prerequisite, right? So programming rest is the second one. So now you see, that's why the stress was given earlier when we discussed the in the past half an hour. We were discussing about the programming. I was giving a lot of weightage to programming because that is the building block. That's actually the fundamental necessity. Okay, so that's the step number 1, right? Fine. So that you can see the step number 2. It says that ML algorithm. It also says DL algorithms. It will also say data engineering. It will also say the computing for AI and ML, right? So again, these points are specifically written, keeping in a broad view that you will not stop studying after machine learning. You will continue. This is what is the expectation. So the point number 2 also has DL, stands for deep learning. So machine learning is a basic step. The upcoming concept, if you are interested to study, will be the deep learning, which is the next level, right? After that, you have data engineering, which is a data science related topic. That's the one which I was mentioning earlier. You can go to the right, go up to a last level, right, until the applications of the data science which you can learn, right? So that's about that. So the fundamental thing is that knowing about what are the various algorithms. You want to apply something, you want to build something after you attain a lot of knowledge, that's for sure. But you should have a very clear-cut idea that what are the algorithms that I need to study. Okay, what are the algorithms? Then how the algorithms are going to work and which algorithm you are going to use, right? If your intention is to solve a particular problem, right? For this problem, this is the best suitable algorithm. for this one, it is the best suitable algorithm. Like that, I should know, right? Then only I'll be in a position that I can apply that and I can work it out, right? So that's why step number 2 is about the theory aspect which I was discussing, right? So the theory part, whichever we are going to discuss, right, will cover that part, the step number 2. Step number 3 is learning tools and using tools. So I had a question that have you used any tools under Python? Because the step number 3 is again a part of coming from the program. So those who are familiar with step number 1, we can start from step number 2, but right, those who have no idea about the programming aspect, I want people to recall, right? So for which we are going to support, don't worry. But step number 1 is very fundamental. Step number 2 is theory part. You will study, you will understand what are the various algorithms, what are the parameters, how they are going to work, right? So that's the second one. Then the third part is learning the tools. You know about Python, but Python uses several libraries, several tools which are built for specific purposes. Okay, you want to build a model, you want to build a program that is going to operate on images, right? Image processing. If you want to do that, you have a specific library for that. Okay, you want to deal with the signals, right? The DSP, signals and systems, etc. If you want to work on that, there is a different library for that. Because you see the applications are different. I will not apply the same functions which are going to be applied for a radar signal or a simple signals and system, anything you take, right? Anything which is there in DSP, filter design, you may not use the same function for images, right? So that's why there is a differentiation, right? So knowing those tools according to your requirement is necessary. So that's what is going to happen in step number 3. All right. So step number 4 will be the implementation. Whatever you have studied, take up a real subject, real problem, and apply them all together so that you have a better result. Okay, so these are the 4 different steps. Now you see, as and when you progress, right? When you actually construct a house, it's the same thing that's happening, right? Foundation and columns are done. That means mathematics in the program. Next, you see the floor installation that is happening at every layer, right? That's nothing but you are learning different algorithms which are going to be the floors of your multi-story building, right? Then learning the tools will help you out how to use the mathematics and the algorithms you used so that you can, right, create something like the wall structures. They are going to support, right? And at the end, you will install the remaining parts like windows, doors, etc., right? That's actually the making your knowledge beautiful by showcasing that, saying that, okay, I'm able to do this project, right? Which is actually a result of all the past 3 steps. All right. So let's directly jump into the concept. So I'm starting with a concept called as a classical program. Now, you know that, right? You have written the codes in various languages so far, right? Let us say you are writing a program in C, right? So I will definitely ask you a question saying that, right? Write a program that converts any entered value in Celsius into the Fahrenheit. So what you will do, right? You'll write a code according to a particular language. If it is Java, you will write in a Java format. If you are writing in any different way, if you are writing it in any other way, right? So you can see that you will write according to the requirements of that particular language, right? So you may ask that, okay, you may ask the user to input a value, right? That value comes into the computer, right? User logic, right? Saying that I know there is an equation. That equation will convert any Celsius into the Fahrenheit. You can see here, right? So if you note on our screen, right, we have an equation saying that this is the logic. What does that logic stand for? This is the equation. For any value C given, simply put it over there. Whatever F you get, that's the answer, right? So in the sense, this is called as a classical program, right? Whatever we were doing so far is classical programming only. Irrespective of which language you use, right? Doesn't matter. It's still the same concept called as classical programming, wherein you know what is the logic, right? In a sense, I am actually going to tell the machine, in the sense computer, saying that, okay, somebody will enter a value called C, put it into the equation 9C by 5 plus 32, whatever answer you get, provide that as answer, your job is done, right? So that is what we have been doing so far in a specific concept called as the classical programming. Agreed? Everything, whatever program you have written, maybe VHDL, maybe MATLAB for DSP, or any other things you have studied so far, right? Everywhere you did the same thing. Agreed? Yes. Put your comments in the chat, because every time we may not get time to have a oral discussion. Okay, so whenever you just want to say yes, no, or something like that, simple answers, please put it in the chat box so that I will come to you, right? Yes, everybody is with me. All right. So my question was, right, so we were doing the classical programming so far. I hope that's the S for everyone. Correct? Fantastic. Now I will go to a next level. This is what we are going to do now. So this is interesting. Let's see. Let me try to define a very simple scenario, just to give a hint that what will be machine learning, right? I will not give any equation, right? Same thing. I'm trying to write a program, but now you see, I will not tell machine that, okay, this is the equation, f equal to 9c by 5 plus 32. No, I'm not telling. What I do, I will give a set of data points. We call it as a data set. So you can see here what a data set looks like. Most of the time, 99% of the time, right, the general machine learning means it is a tabular data. So you can see a table here, right? Several rows and columns. That's all. Okay, few rows, few columns. In this case, it is a very simple case, but practically you will never get the simplest tables like this. Practically, you will get something like 1 lakh rows, right? 20,000 columns. See the size of the data set which we are talking about when it comes to the practical scenario, right? Anyway, that comes at a later stage. Let's push it away. Right now, the example says that I have, say, 3, 4, 6 rows, 2 columns. What I'm giving, I'm simply giving input that if this value of Celsius is given as input, you should give an output 93.2. Okay, like that, I have a set with me. Okay, I have set of values 34, 35, 34.4, 36.2, etc. Many values I have written. I may give few more values like 10 rows, 2 columns. Always it will be 2 columns because Celsius is my input, Fahrenheit is my output. Right. But now you see, I'm not going to give any rule saying that this is the equation that is used to convert a Celsius into Fahrenheit. Okay, I'm not giving the machine. I'm not giving. Normally, when I say machine, it is computer. Okay, so because most of the time I use the word machine whenever I discuss the various topics. All right. So just remember, the machine is another word I use for hardware, or in general, it is computer. Okay, so I can see that I'm providing only this as my input. I'm not providing anything else, right, for the computer, right? So I'm not providing anything else. So that means you can see, right, now the job of the computer is that to learn that when this is the input, this is the required output, next input, next output, next input, next output. It itself has to identify what is the rule, right? So actually it's a easier work for me, right? Previously I only have to identify, okay, this is the input, this is the output, means what is the relationship. I have to tell the machine that this is the particular logic that needs to be used to convert this input into this output. But now you see, in case of machine learning, our job becomes actually easy, right? I just have to tell, okay, this is my input, this is my output, right? Now you are making the machine to learn that logic which generates an input to a corresponding output. Now again, this problem is pretty simple, saying that, right, This is the input given, one output. But generally what happens is, right, whenever you give many inputs, like not just one input, 1, 2, 3, 4, my table may be larger, right? Output is only one, but inputs are many, let's say. Okay. So when such cases happen, right, machine, it is actually a tougher job for machine to decide what is the function, right? So that's what is the ultimate idea. Without giving any hint that okay, this will be the function, I simply provide input, and machine should be able to, right, guess what is the function that generates output. But I definitely provide this is the required output, right? Without that, it is not going to happen, right? So either you go for a classical programming where you give input and the set of rules so that it provides them. But now in machine learning, I give input, I give output. I don't say what is there in the middle, right? So there is a blank, there is a black box, question mark. That is the job of the machine to decide, right, what is the best suitable function for which can generate this output for a given input. I hope it is clear. So this is what is a very fundamental idea. So now we see, this is what I do. So in case of a classical programming, if we are looking at a classical programming, I give the rule and I give the input data in Celsius, right? The rule which is the equation. So classical programming, whenever you write a code, you get the output that is in the Fahrenheit, right? But now you see, I am going to give the input that is in Celsius. I am going to give the answer that is in the Fahrenheit, but this is not known to the machine. Using the machine learning algorithms, it is able to identify which is the best suitable equation that or the logic that actually converts your input into output. So what you are generating is the set of rules. So this is the very fundamental difference. Okay. Now, what is the requirement? I have a question. Why do you want to do this? If the classical programming is working fine for you, why do you need this? Is my question. Anybody? Please feel to ask. It's going to be an interactive session, right? So I expect everyone to participate, right? I'm not expecting a perfect answer. Don't worry, nobody is perfect, right? So please go ahead. Please put your answer. Let's discuss. So this will I expect this to be rather than one-sided. I expect this to be a pretty much interactive session. All right. So please put your answer. What's your thought? Why you need this? I repeat the question. So far, we were doing the classical programming, and I'm very fine with that. Everything is working fine for us. Why do you want to go to make things difficult for us? Because writing a machine learning algorithm may be difficult job. Right? So the application may be, sorry, very simple. I'll just give an image saying that, okay, identify this, cat or dog. Machine will say it is dog. It is done. But how do you make sure that machine learns that this is how a dog looks like? This is how a cat looks like. That teaching is difficult, right? So why do you want things to get difficult, right? When you actually have the classical programming approach already available, is my question. Yes, anybody? Just think over it, right? Now, what do you think, right? What do you think about this? That's all. I'm not expecting an answer, right? So I'm not saying that you have to answer my question, right? So I want you to participate, right? Participate in the discussion. No oral answers, absolutely fine. If you have some thoughts, at least type in the chat. I will see that, right? So that things will go ahead, right? Otherwise, it will get stuck here. That unless you give an answer, I will not go ahead, right? So somebody has to enter, somebody has to interfere and give me an answer. Then we'll proceed. Otherwise, it will stop.
Hello, sir.
Yes, Kannad, please go ahead.
Sir, I think that classical programming has its own limit. I think by using machine learning, we can like in few cases like detection of things and all. That classical programming, I think it can't work that much efficient as machine learning.
Yes.
So we are using machine learning.
Yes. That's good. That's good approach, right? I like that. So coming to the answer, whenever the data set, I'll try to put his answer only, right? With just changing the words. He actually has given the right answer. So the idea is that whenever the data set is very simple like this, right? The one which I said, like This is easier. You may think that classical program itself should work fine because the equation is very simple. 9c by 5 plus 32 should give me an answer, right? But now you see, I want to detect the, maybe I want to estimate the price of a house depending upon various parameters, right? If I try to generate a particular data set corresponding to the house price prediction of certain city, let us assume, what are the things you have? Where is it located, right? Maybe that location will contain, it's a geographical location, so you may have XYZ coordinate or any other parameter. So 3 columns done. Let's keep the count, okay? 3 columns on that. Then maybe the next one will be, if you want to give more details, more specific, you may also enter the pin code for that, column number 4. Next, the number of maybe rooms, bedrooms present over there, total built up space, number 7. Then you may also enter what type of flooring you have done. Then also you may enter few more things about that. Let's say this will go up to 10 to 15 number of columns. How many times it has been sold? What is the total number of years, right? Which actually it's standing for, and many other parameters also, maybe, right? Like number of floors, right? Many things, right? So you can see that up to, it may go up to 15 different columns. Now you see, previous example was just one input, one output. Now I have to use 15 different inputs to guess the 16th column, that is the price, right? So classical programming is going to fail there because you don't have any equation saying that 60 inputs provide all together giving you a price as answer, right? So that's actually a difficult job, right? So in other words, right, adding something more to the what Sanath has told, right? So classical programming fails when you have more number of columns in the data set, in the sense that data is higher dimension. When you say only one value, it is said to be one dimensional, right? You know the dimensions, right? Dimensions of signal, you might have already studied. One dimensional, image is 2 dimensional, and so on. Movie is 3 dimensional, right? Okay. So, right, whenever the data is of higher dimensional, right, we will never get any logic which justifies that for this input, this is the output using the classical. So, right, classical itself becomes more difficult compared to what we are going to do in machine learning when your data set is of complex nature. In the sense, not complex numbers, complex in the sense more number of dimensions, more columns, right? So that is the reason why, right, machine learning came into picture, and that's actually making things easier for us, right, compared to the classical programming for those type of data points. Okay, so in the next slide, you can see that what is this all about. We said many times we hear, right, whenever you go for a technical talk, right, you go to a technical magazine, you read a technical magazine, visit any technical discussion center, or listen to some technical discussion happening on the television, definitely you'll see these words repeating: artificial intelligence, machine learning, deep learning, because that's in boom now. It will be there in boom for next 15 years at least, right? So make a note, this is 2022, right? 15 years from now also you will hear this, because this is the era of what we call as AI, ML, DL, data science, etc. Right? So a lot of things are there. Those who, right, actually do something really good, do a good study, do a good project, and right, do something in this, you have a good future over there, right? So, right, you can see here. Now let us see what we are discussing. Overall, we'll see it now. So, right, artificial intelligence, right, is something like you are making the machine not just to decide something, but to learn something. You make the machine to learn and take a decision by itself, right? Something like what we do now. Always I'll decide, okay, whether to turn fan on or not, right? Whether I should sit or not, whether I should do something or not. Every time you keep taking decisions, right? In a day, we will definitely take more than 300 decisions, right? Based on some knowledge which we have. Same thing if you want to make the machines to do that, that's what is AI. So the whole AI actually stands over here. So this is what is AI about, right? And there is another which is larger field coming up, right? Again, I have denoted that as a data science. that is all about the data. This is in boom now because every company, every industry you see now, they are actually working in at least last 20, 25 years. The giants which we are talking about, tech giants, whichever we call, right? Right? They are there in the industry since last 20 years. Since the 20 years, they have collected each and every data with them. Everything, like you see the Google, it is actually asking each and every information from you from your phone. It is taking everything. They will definitely store it, right? So at what time, who searched what, right? And who is asking currently this location in India, in Karnataka, in Bengaluru, in this region, people are searching what, right? Everything will be noted down over there with the timestamp. They have such a huge data available with them. Not only Google, I'm generally talking about whichever company which is there in the industry since last 20 years, they have not in terabytes, right? So crores of terabytes they have data set with them. What to do with data, right? So there was an idea that since we already have this much data, can we do a prediction, right? Can we use this data to predict something so that we can improve our business ultimately to make more money, right? So the business analytic was the field which came into picture. Business analytic using already whatever data they have, right? People are trying to explore that. With my past data, can I do something which is going to help me in future, right? Because everything has some pattern. So you may maybe you are aware of people who are actually continuously following the stock market, right? So those who know that in the depth knowledge of that, they will be able to predict what is going to happen next, right? So maybe Monday this particular stock may increase, right? Let me put some money over there. This is what is happening, right? Same thing if you use the NSE stock data for last 10 years and you know the machine learning, you know deep learning, you will also be able to do that. Okay, so that's what is the idea. You use a data set, you know how to implement some what you call do some programming and right, do some apply that, build some applications and that, and means you will be able to do that's what is the whole idea. So comparatively you can simply say that it's just like stock market. I have last 10-20 years of data, I can predict what is going to happen next, right? So extracting the various patterns from data and using that data so that, right, it is going to be helpful basically to make money. That's the overall big picture, right? So the data which you have, you can process that data in various types. So that data is what we have represented over here, right? That is the bigger circle. So now you understand that data, if you want to use for something, you may also have to use what is called as AI. Okay, that is the AI part. Now, between the AI and the data science, you have one important part which we are going to touch now, that is the machine learning. All right. So machine learning is actually in the middle. It uses a lot of data, right? It also uses AI to build the algorithms. All right, fine. Let's look at the data. Let's move inside the data and see what all the things you can do. I have a data. I can try to define a problem. Define a problem like the one example which I told. I have a data set of uh, maybe the data set of complete country related to the house price prediction. I want to do a prediction, but every in this location, if the house size is this much bigger, plot size is this much bigger, this is the price. Like that, I have the data set for, let me not say the whole country, let me say for a complete city. Now the problem definition could be something that is like, where should I put my money right now so that I can get double after 4 years? See, that's the problem formation. I found a problem. I have to use this data. I have to come right to this and I should solve. Machine should tell me that, okay, you put your money here, in a sense, in this particular location, buy 1 or 2 houses over there. In 4 years, there will be a boom. You will get double of money, right? So that's what is the problem formation. Okay, so as you have a data, right, there is a part called as a big data, right? This is the big data is the one which actually I was telling earlier. Like every company, everywhere you will see data. They have, right? We cannot imagine how much data they have, right? So much is covered. right? So that's what is a big data. Now I'll try to give a simple definition to the big data. Big data is a point which your computer RAM cannot hold. That is the size, right? You may have 32 GB RAM for the time being, let's say. Whatever that is not, you are not able to hold in that, right? At a given point of time, we call that as a big data. That's the simplest definition, right? You refer other books, you get any other definition, but this is from my practice. So my knowledge, what I'm saying is that I may have a lot of space in my computer hard disk. My hard disk is maybe 1 TB, 2 TB. But in order to apply an algorithm to the data which I have in my computer, I have to bring everything onto which location? I have to bring everything to the computer RAM. RAM is the place where you actually execute. After you apply, after you process your data, you will put it back to the computer hard disk where you have a lot of memory, no problem. But the problem lies if I have 32 GB RAM, but still it is not sufficient because my data is big. That is the point. That's what is big data. As of now, you may not have come across any such data which you can imagine saying that, oh, this is a big data. But we practically have such big data. It is impossible to bring everything onto a computer. Computer will hang if you try to bring that. Okay. So whenever you want to run such data, you have to go for a different approach, right? A lot of computer architecture also comes into picture. Again, you should have a knowledge of how to deal with what is called as the servers. Server side programming is also a little bit required over there. Okay. Anyway, we are not going to touch that because you see it is actually right. It actually overlaps a small portion of our ML. As of now, you don't worry about that. We are not touching that. Okay. Because you see, if you want to handle that, you have to use what is called as a DL. As I told, machine learning and deep learning. Right. So the next level is deep learning. There, those who are interested, they will study that. Okay. So as of now, we are not touching that, but still I'm trying to give you an idea what this whole world of AI, ML, DL, any word will come into you come in front of you. Now onwards, you will have a picture. Okay, this is what he's talking about. I understand. Okay, so that's what is. This is ML, this is DL, and the link between ML and DL, because ML came earlier. ML is actually in the business since almost 10 years now. Everybody is using machine learning algorithm, but deep learning is upcoming technology, right? Maybe after 5 years, everybody will start using DL, but nowadays everybody is using ML, right? So ML to DL, that jump, right? If you want to jump from ML to DL, there is an intermediate, there is a blank space between them. You need to study something more over there to feel that. That is called as NN. NN means neural network. Okay, so definitely you will have one subject that is mostly an elective, right, called artificial neural network. So if that comes to your mind, you think that, okay, this is what it's going to teach. Okay, you are going to study that between. So ML there, right, DL here, you fill up the space by using the concept called neural network. So here also you can see the same representation, right? Between ML and DL, I have that. Right, so DL is the one which is used, deep learning is used, right, mainly for the big data applications. So inside this data science, right, you have various other fields also, right? One example I gave, problem formation. Then another complete new field called data engineering. Search in Google, you will get a good idea. Okay, I'm not going to touch that. Then there is what is called as IoT, right, Internet of Things. You might have heard of. That's actually a part of data science. Then data stories. I have so much of data. I use the data in this fashion, so that resulted in this. If you try to write a story, right? So data storying is also very important aspect of the data science. Okay, so that is a data story. And the last part, right, is data visualization. Because when I say my data set is 1 lakh rows and 20,000 columns, when I see that, it's impossible to visualize that by opening a spreadsheet, because spreadsheet, if it is having just like 20-30 columns, I don't understand it. How can you understand when the data is 20,000 columns and 1 lakh rows? Is it possible to visualize? Is it, in a sense, is it possible to just open a spreadsheet, Excel sheet, and understand what is happening there? No way. You have to use, right, some tools which will give you an idea, which will give a picture of that. Maybe a simple graph like maybe a pie chart, right? Possible, right? Maybe a pie chart can give you some idea about that. Okay, in your data set, 20% of data belongs to this category, 30% this, like etc. Like that, you actually see and understand something. You plot, you see, you analyze, you get the information. That part of data is called as the data visualization. I hope it is clear, right? So now what we are talking about is this circle, right? Okay, I'm open for questions. Anything you have very related to this or what we discussed before this, please go ahead. Any doubt you have, you please go ahead. You can type in chat, I will answer that. You can go ahead orally, I will answer that as well. Okay, so that's good, right? Now it's 3:45. Okay, we'll have a 15 minutes break. Take a time, have a tea, right? And come back here at 4 p.m. We'll resume. Okay, you don't have to log out of the this meeting, right? Simply go away and come back. Okay, at 4 I'll resume. So far, we were discussing about what do we mean by the words AI, ML, DL, data science, etc. Right? Whenever somebody uses those words, right? Now you should be able to in a position to understand that and to participate in that discussion. All right. Okay. Let's see how much you have understood so far. Okay. This is a compulsory quiz. Everybody has to answer. Right. Doesn't matter. Whatever you have understood, you have to answer. Okay. So, right. It's a true false question. Right. The way to answer this question is using the chat box. All right. So you have to put, right? If your answer is true, you will put a T over there. If your answer is false, you will put an F over there. And what you do, this is how you answer. All the three answers you give at once, like T, T, T. If your answers are true, 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 you put T, T, T over there, right? If your answer is false, true, false, F, T, F. All right. And so on. Right. So, yes, please go ahead. Yeah, all the three together, Vandana. So please put like, if you want to give, hold on, don't give answer one by one, right? So you decide all your answers like true, false, 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 three, whatever, right? So all the three together. Yes. Take your time. I give 1 minute of time so that you can think, right? Recall what we have done so far and answer. I hope I'm audible now.
Yes, sir.
Yes. Fantastic. Okay. Right. So there will be regular quizzes, okay, just to understand, right, what's your approach and how much you are understanding, right, just to guess that, as well as to do an evaluation. It's a continuous evaluation throughout the internship, that how much, right, what are the capabilities, how much you are understanding, what's your approach to solve a problem, etc. It will be there, right, always. And right, it's a part of our whole program. Okay. All right. So the first question: AI is a subset of ML. So knowing the idea of a subset is important. Subset in the sense AI should be inside ML. If I draw the set theory, right? Go back to the set theory. AI is a subset of ML means AI should be inside. So is that what is this case? You see, AI is inside ML or ML is inside AI. So ML is a subset, not AI is a subset. Okay. So the answer to the first question is right, as most of you have answered that right correctly, so that is a false. Okay, so the second part, DL is separate from ML, right? So DL is separate in the sense, right, DL should be here, right? ML should be completely outside. They should not be any link, any part of the circle should not overlap with that. That's a question if it is separate, but just go back and check, right? It's not like that, right? So DL is actually present inside the ML only. So they are not actually separate. DL is an upgraded version, right? It's a new technology which is built up based on the ML techniques only, right? So for that reason, so the second answer becomes false. All right. And the last one, ML discovers rules from data and answer, right? I give a data, I'll say that this is my answer required, and the machine learning says that, okay, these are the rules, right, which actually can relate or can map the data to the answers, right? So that's why this is equal to a true statement. All right, moving ahead. Now let's go further. Let's discover something more now, right? What is a data and what is an information, right? So this is pretty much important, right? So let's start with that. Let's consider a scorecard of Virat Kohli, right? You can see here. All right. So this means, right, it's the scores by innings in one-day international games, right? In the past, let us see. Right. If I give that, right, will you get any information from that is my question. What is the, if yes, right, you need to say what information you get if I show you that the whole table as it is to you now, right? I will show you that and I'll ask you what information do you get, right? What is your answer, right? You can give oral answer, you can type, right? I suggest anything you can do. Yes, please go ahead, right? If so, question is very simple. I have a table in front of you. What is the information you get from that? Specific to that question only you can answer. From this particular table of Virat Kohli's score, I will understand this. Okay, we have one answer saying that batting average. Okay, good. Let's see. Other answers. Please go ahead. Only average. So Vivek says he comes to know about average from that particular table. Maybe, right? What else? What else? Is that the only thing you come to know? Best performance, in which match he scored highest, maybe that's what you get. Or somebody may say that what's the highest strike rate I may get that, right? Okay, possible. Yes, that's good, right? Okay, now at which venues? Yes, yeah, that's also right. Which location he played, etc. Also, we will come to know. Total score, yes, Stephen, that's right. Now you see, right? We have our own views on this. Now I ask you a question. Whenever Virat Kohli comes for batting, right, at a particular location, at a particular match, right? If the star sports shows you this whole table, will you like that? Is my question. Will you like that? They will simply show you that, okay, this is what is corresponding to Virat Kohli, right? Will you like that being displayed or do you expect something else? Is my question. What do you like? What do you like to see whenever a batsman comes to ground saying for playing? Because somebody got out, he is coming in as the next batsman. The whoever is telecasting, right? Maybe Star Sports or whoever, they will show you the whole big picture, the whole table in front of you. Do you like that? Is my question. Obviously, no. Because what's the reason? What do you expect? Because nowadays, whatever they show is what we expect. Why that? Anybody? Obviously, we haven't answered no. That's right. Why is my question? Why don't you like that? Right? Anyway, I'll go ahead with the answer. Right? They will show you something like this. Yes, no patience to read the whole thing, right? Absolutely, right? Nobody will go through that. Because what they want is information, not data. So you see the difference now. The whole table, if you show, what you are showing is a data, right? Data may not be useful all the time. What is important, what is useful is information. Now you see the carrier summary is the information, If they give this, you will understand, okay, his score is this, his best average is this, his highest run is this, he has played so many matches, right? Most of the content in the tabular data is not useful. Who wants which location he played so many times? I am not interested. Nobody will be interested. That's why career summary will never show that information. Correct? Are you okay with that? Are you with me? Right? So information is different and the data is different. Data is actually too huge. It may or may not give you the complete information, but definitely information is something different which actually provides an insightful, right? Insightful view of the whole table. It is understood, you can understand what is the situation that somebody is trying to convey you. Okay, so these are the various parameters related to the information. And right, the example is this is a data, this is the information. Okay, I hope this is clear. Just try to understand things. I'm trying to keep everything as easy as possible. I'm not bringing most of the equations, nothing. Okay, so just try to understand this. Now, we understood data. From data, coming to the information is not so easy. Right? So what is my intention? What I want to look inside this data so that I can convey an information to you is important. How do you do that? You will do what is called as a data analytics, right? I have a data set with me, right? I may have to classify the data. I may have to guess what is going to happen next, or many types of problems you can form, right? I think by now you already have an idea what and all we can do with the data, right? So if you have a data, in order to get an insight of that data so that I can extract some information from that and I can process that and I can try to solve some problem. In order to do that, right, what all the various things we are going to do, it's actually under a particular side heading called as a data analytics, right? So you can see a big picture over here, right? The big picture actually is, right, divided into 4 different parts. The first type of analysis is called as a descriptive analytics, right? From the data, you should be able to, if the question that you are trying to answer from the given data is what happened, right? Question is what happened. You see the data and you are trying to answer that. Then what you are trying to do is your analysis is called as a descriptive analytics. You are trying to discuss, right? Describe what is happening in that data. That's all. Okay. Now, from the same data, if the question asked is not what happened, right? Why happened and what is the cause behind that? If that kind of question is asked, then your analysis is called as diagnostic. Okay, so you can see here what are the various tools used. Also, I have specified, but as of now, I'm not touching that. It's you can understand. So whatever is mentioned as the foundation, they are the prerequisites if you want to understand. Okay, statistics, matrix algebra, data visualization techniques, various tools are there. You have to be familiar with them if you want to answer that. So similarly, you can see here, diagnostic means you have to answer using the probability and the statistics there. Those are the must-haves if you want to do this kind of analysis. And which tools you use in maths, what you use in probability statistics, you use correlation, covariance, entropy, mutual information. I think everything you are aware of, every word you have heard. In one of the other subject, you have these terms. So you should be able to recall. If you are not able to recall, go back, right? See, take a textbook, see, just read that. What do you mean by correlation? What is the equation to do? Calculate that. And how to calculate. At least this thing you have to do. This is a homework for you. Right? In this slide, every word which we have here, you are not able to recall, go back after the class. That will be a homework part for today. Okay? Every word you should be able to recall, right? Because we'll just bring the terms as and when we require in our course. Okay? You have to be in a situation that, okay, this means this, this means this, this means this. Okay? So in which maybe data visualization is what you have not touched. Okay? So don't worry. Whatever is not covered, whatever you have never dealt in your engineering so far, no problem. Just leave it. Other than that, I am expecting everything. Okay, so here you see correlation, covariance, entropy, etc. Everything is there. I know, right? Everything has been covered. So don't worry about the data visualization. Okay, So, right, then we move ahead. Next question. Maybe with the same data, maybe there is a question that what is going to happen next? So you see, it's that problem. I have, right, a data set. I want to predict what's going to happen in future. After 4 years, where I get my money doubled, right? So you see, that's the question. What's going to happen next? If you want to do that, then I have to go ahead and I need to use MLDL model, time series model. This is what is required. You have not covered, just leave it. No problem. Okay, but I want you to recall the fundamentals from probability, calculus, and the matrix algebra. Okay, right. Then the next type of analysis is what is the action to take for the required result? That's my actual question earlier, right? Where I should invest so that my money get doubled. My money getting doubled is my problem. What action I am supposed to do, right? Machine may give me an answer that buy 2 houses at this location, right? So that you see, that's the action taking. So this is what is called as a prescriptive analysis. Okay, so 4 types of analysis that can be done from a data. Now, it is absolutely not necessary to do all the analysis for a given problem. Look at your problem. My problem says I just want to do a classification. You don't have to do what is going to happen next, or what is the reason for, etc. Not required. Just look at the problem, try to pick up an analysis so that helps you in getting your answer. Okay, 4 types of analysis are there. All the 4 may or may not required for a given problem. This is the overall highlight which you should understand from this particular slide. Okay, all right, let's move ahead. Now I use a word called histogram, right? So if you have never used that so far, right, I'll try to give a very quick picture about that. Because histogram is one such plotting which helps you out in understanding the from a data. I can get a simple picture out of what is there in the data. I'll come to know, right? If I use a histogram is one most common thing. That's why I'm using here. I'm not bringing any other visualization in today's section. Okay, but you see here, what is a histogram? Just try to understand, right? It's a Virat score, right? Starting from 0 to 200. Along the x-axis, we have runs plot, right? So along vertical axis, how many times he repeated? Now, what is your conclusion? If I show you this, what do you understand? What do you understand if I show this, something like this, right? If something like this comes, if Star Sports showed you this, right? Whenever they are discussing about Virat Kohli, what do you understand? Yes? Anyone? What do you understand? This is the one where very common tool used for right, conveying some information. So that's why I'm asking. You might have seen this kind of representation at many places. So look at the vertical axis. It says frequency. Frequency doesn't how many times he did that. So you see the 0 to 50 is actually divided, right, into approximately 3 pieces. In the sense, each piece may come as approximately maybe 18 or something, 17 to 18. So 0 to 17, he actually, right, got out between 0 to 17 so many times, more than 90 times. Okay, so then 70 to 17, 17 or 18, 18 to 35, between that he got out approximately 40 times, right? You see, this is the information you get, isn't it? So histogram is, right, this information, right? So how many times something happens in your data, right? How many times a particular value repeats in your data? You want to visualize means you use a particular type of visualization that is called as histogram. Now, so histogram says that, okay, so there is a value for this, next value is this, next value is this, next value is this, like that. I have various values present. So this is what is called as a distribution, right? His runs and are actually said to be distributed, right, between 0 to 200 in so many fashion. So that's what is the term distribution. You already have come across the distribution when you studied the probability distribution. That is the distribution of probabilities. PDF, etc. You have studied in the probability, correct? So I want you to recall that. All right, because of this. Fine, let's go ahead. Now, the next topic is, okay, this you can read here. So now, so there was something like what happened. If the question is just like what happened, the previous slide actually answered that. So he got out these many times for this, these many times for this, these many times like this. This is what happened, correct? Just to answer that, you need only that plot, right? So you see, visualization helped me in understanding what was there in that big table. I just show you that table. You have to keep counting how many times he got out for this number, how many times. You have to do a lot of calculation. But you bring up that one single graph, everything is understood. So that's what is important. Now, right now you see that maybe another question I'm going to ask is why he scored right less than 25 in more than 90 minutes, right? 90 plus the first right tall part of the chart which says right 0 to something is more than 90, right? Now you need to answer that question, means you have to do right, you have to dig the data a little bit more. Maybe your answers could be possibly right, depends upon who was the opposition, what innings, which pitch, etc. You need to do little bit more analysis. Okay, so that's what is required. So in order to answer that, you will go for right another type of analysis that is called as hypothesis testing, and go to understand, to recall these concepts, go back, take engineering mathematics textbook, whichever part had the statistics over there and hypothesis testing were there, right? I want you to recall that, right? This is another part, very important. You have to do this. Okay, so that's the next part which I expect everyone to do, right? Not immediately, when we actually implement the machine learning algorithms, right, by doing a coding or by analyzing various data set. I want you to be ready with this. Okay, you have some time, but don't take it as too much time, because if you keep delaying things, later on many other homeworks will come. There you will get right, you'll get messed up. So as and when you get time, right, just note what I'm saying. Please do that as early as possible. Okay, so you see the next possible question could be right, what will Virat score in the next match? What do you do? So I have so much of data, I can use it and I can make a prediction. So that's what is going to come into picture in the predictive analysis. So for that, right, our simple mathematics, etc., will not come into picture. I cannot use a simple visualization. I cannot use a graph to give an answer to that. I have to go to the ML models, machine learning models will come into picture in that. Okay, fine. I think you have a big picture now. Let's go to the subcategories of machine learning. What exactly machine learning is, we know now. I have a big picture. Let's go one step into that. So you see the machine learning as a whole is divided into three major parts. One is called as supervised learning, another one is called as unsupervised learning, and the third part is called as a reinforcement learning. Okay, so let's say the first part. I'm going to start with the supervised learning. So supervised learning is something like, I have a data set with me. Let's say it is a table. Tabular data is there. Okay, in the tabular data, right, my objective is to do a classification. Something like, I have a data set. From that, I want to say that is it related to maybe it can be audio. Okay, it can be photos, it can be pictures or something. If my objective is to say that is, maybe I'll go for a much simpler example. Say I have two pictures, cat and dog, right? From that, right, I give an input to the machine. Machine should say that whether it is a cat or dog. You see, you are trying to do a classification. So supervise the learning, in a sense, I teach the machine. I'll say that, okay, I give an input. I'll tell the machine that, okay, this is the expected answer, right? So machine tries to fill the blank in the middle. So, and ultimately when I do a testing in the sense, after I teach the machine, it's something like your exam. We take classes with the students, right? And I will ask questions at the end, saying that just to understand that how much you understood, and maybe we'll give a score out of it, saying that out of 100, this is your score. Similar thing we do with that, right? During the testing, I give an unknown data to the machine. Machine should be able to classify that. Okay, this given image is a cat. This given image is a dog, right? So if that is the case, so that comes under this side. Okay, that is a classification task. Then we have another thing that is called as a regression. It is very similar to the previous case, but you are trying to guess the value, right? For example, I give all my data set and my requirement is not to do a classification, but to estimate what is going to happen next, right? You are going to predict something, right? If that is the case, right, then this is going to be called as the regression problem. One best, I have given many examples over there, right? You can read it at your convenient time. The best example I'm going to give you is, I have last 10 years data corresponding to a stock exchange, particular stock, right? I'll give that. I'm asking machine what's going to happen on when the stock market opens on Monday. So you see, it is not going to say yes or no. It's not going to say dog, cat, something like. It will give a number, right, to you, which is a real number. It can be 25.35, it can be 25.8888, anything like that. It's a continuous number that is getting generated. So I am asking the machine to, right, generate a continuous number, right? Anything which is continuous, right? So that is why it's falling under another case called as a regression. Okay, so right, classification, regression coming under the supervised learning. There is a supervision that is happening. I'll teach. Every time I teach, I'll check whether you are learning or not. At the end, I'll do a testing. And on the other side, we have another type of tasks which are called as unsupervised learning. Unsupervised learning is something like, I have a data point, I have data with me, but I don't know the number of classes in it, right? I want machine itself to decide. Okay, so under such case, right, the first type of solution is that machine will decide, okay, there are 3 classes in this data set. Okay, if you want machine to decide that and perform the required steps and learn that, then that is what is called as a, right, clustering. It is called as a clustering. You are trying to form the clusters in your data set. At the same time, my data set is, like I told, we may have a data set which contains 20,000 rows, sorry, 20,000 columns or something. So whenever that is a case, you see that when we have such a huge data, normally it is difficult even for a computer to process that. So what you do, you ask the machine to reduce the unwanted column, remove the unwanted columns by yourself. Okay, you can ask the machine to do that. That's also a part of machine learning only. So you see, it is called as what? It is called as the dimensionality reduction. Can you see that? It is called as what? It is called as dimensionality reduction. All right, fine. Then the third part is called as the reinforcement learning. So reinforcement learning is something related to automate. So I'll directly give you an example so that you understand what you will do, right? Right. So it's automatic driving cars. You want to build something like that. That's actually coming in the reinforcement learning. Okay, robots, right? You want to self-talking robots. You want to build something like that. Yes, that falls under the reinforcement learning. Okay, so right, fundamentally you understand that there are, right, 3 major parts, right? The whole machine learning is divided into 3 parts, right? Supervised, unsupervised, reinforcement learning. Every part has its own type of applications, and it's not necessary that, okay, it falls only under supervised, I just have to learn supervised. No, right? There can be overlap. In your project, a part of that will be supervised, part of that will be unsupervised, and any mixture of that will be possible. So our intention here is to go through everything in a pretty detailed fashion. Okay, all right, so it's a time for quiz number 2. Okay, look at the question, whatever is given over here, and your answer will be just like, if answer for the first question is C, you just write C, comma, next answer, whichever you think is your answer, like A, like C, comma A, like that. In that format, I'm expecting you to answer. All right, please take your time, maybe maximum 2 minutes. Within that, I'm expecting everyone's answer. All right, so we have all the answers with us. So yes, It's correct answer. I think all of you have given the right answer. So a system which takes rules and data is to give answers, right? Is what it is called as a classical programming, right? And what are the foundations needed for descriptive analysis? You want to describe something means yes, you have to know the concepts of probability too. All right, fantastic. Okay, let's proceed further. So now I want you to understand this. It is called as a machine learning workflow. Whenever we are facing a problem and we want to solve that, right? We want to solve that, right? What is the normal flow in which, right? Normal flow of implementing any algorithm, right? Will be having 6 different steps. Okay, so the step number 1 is frame the problem, right? Problem forming is important, right? Again, I have given this with the business need, because ultimately every company is working so that they can make some money. They will make money, they will give a share to their employees so that employees can also grow, right? So it's ultimately the same thing. So I have added the business need over it. Okay, so inside that, right, what the major problem may be subdivided into little small sub problems, and you may have to define, right, what is the acceptable answer, right? If you get 80%, that is good for me, something like that. You define a goal, right? So that is what is the success. Anything more than that, I'm okay with that, right? So at least something I shall have to get that. So how to approach that? It actually includes what is called as, right, establishing the baseline and also defining what is the success, right? So that's the first part. In order to do that, definitely you will start with what is called as the gathering the data. I'll gather my data set. I'll try to collect, right? And collecting, after I collect the data, I need to have an insight of data, right? How to get the insight? What are the options you have, right? We will be discussing that at a later stage. But on a broader side, this is what is called as data munging and data wrangling, right? So in that you have something like exploring the data, right? You do a visualization, understand how many times this has happened, and understand like what is the mean, what is the variance, what is covariance, etc. Depending upon, right, your approach to solve the problem, you will solve it, because data analysis has 4 different parts. Already you understood that, right? Out of which, according to your requirement, you apply. That's what is exploration of the data analysis. And normally the data which you collect is not clean, right? It's a raw data. There's some values are missing, right? Something is just blank, right? And some outliers are there because of the noise present, etc. Many things are there, right? So you need to perform what is called as, you have to clean the data and align the data in order so that it can be given to the machine learning model at the next stage. So this is what is step number 2. Okay, out of this, most of the things are new to you, so there is no homework associated to these topics at all, right? So whatever I requested earlier, just concentrate on that when it comes to the whatever you have to study today. Okay, fine. Then the next part is explore, perform, visualize, shortlist the candidates. In the sense, machine learning, whichever algorithm that we are going to study in the upcoming sessions, right? Out of that, you may try to implement everything, because we have no idea which particular algorithm is going to work better, which is the best one for this problem. Mostly I don't have any idea. So what I do, I'll try to explore this. I'll try to build the model, I'll try to measure the performance, and I pick out of all of them, out of say 10-20 algorithms which I know. I'll implement each and everything, and I'll see that, okay, out of these 4 or 5 or 10, whatever we have, okay, this is the best one, right? Or these are the best ones. I'll say shortlist the promising candidates, right? So candidates, in the sense, you are trying to shortlist, right? Out of those, which are the best accuracy you are providing, right? You are getting best accuracies from which all model, you will shortlist that. Then fine tune. There is a step called fine tuning, so that, right, either you fine tune each individual model, or you try to club them to get a hybridized model, so that, right, you may still try to improve the performance. Individually, they are giving 80, 85 or something like that, maybe. And when you club them to get a hybrid model, maybe you will get 90%. So that's what is more something like more fascinating, right? So that's what is the step number 4. Then the step number 5 is present a solution, right? Starting from step number 1 to step number 4, we have done a lot of job, right? So remember, this is what you are going to do. We will be giving you a problem, right? Step-by-step procedure. These are the 6 steps you will be doing at the end, right? You have all the 6 steps in your hand, right? At the end means, yes, you are following the same steps to get your answer. Okay, fine. So present your solution means, yes, simply, right, write your code in a neat fashion so that, yes, whoever is going to read that will understand. Otherwise, you, right, bring some plots in the middle so that everybody can understand, okay, this is what is happening in the middle. So that's what is the story of your data. Last part will be deployment, which is, right, you may have to monitor the performance for various other data sets which you have not used, gather an updated data and try testing with that. And you may want to repeat anything which is there in step number 1 to 5 again and again, so that you, right, you improve your performance. Okay, so this 6 steps, whatever you see here, right, that actually constitutes our machine learning workflow, right? So what are the different steps in which you have to approach any problem? This is that. Right? In the middle, step number 2, what are the options I have? We have to study. Step number 3, what are the options we have? We will see that. Okay, like that. So this is just a overall big picture, right? But in order to solve any ML problem, this will be the workflow. General workflow is this. Okay, right. Now I need to give another introduction part that is related to the types of data that we face. Whenever you, right, collect the data to solve some sort of problem, various types and formats we get the data, right? It may be written in any file, it may be present in anywhere, it may be present in your local drive, it may be present in your friend's phone, it may be present in a local cloud, it may be present in a faraway cloud, doesn't matter where it is, right? Types of data, right, is also important. So the first one you see is called as a tabular data. Most common one, I already told that most of the time you get the tabular format, right? So many rows, so many columns will be there in that. Okay, so that's the first thing, right, that you need to understand when we say that tabular data is my format. So second one is time series. Time series in the sense it's actually similar to the tabular data, but collected at different intervals of time. For example, the stock data. The data is corresponding to the same stock, but I am collecting at different time intervals. In the sense, today evening, tomorrow evening, day after tomorrow, like that, one full year I collect. You see, it's the same data, but collected at different time intervals. So that's what, in some ordering of time, if you collect a data, that is the tabular time series data. If you are building a weather station, you may have to collect the temperature data from your temperature sensor, give it to a computer and store it over there. That's also a time series data, because you are collecting the information from a particular sensor at different intervals of time. All right, then another very famous data which we may face is image data set, right? Image it's a 2-dimensional data, x and y you have. At various x and y coordinates, you have different brightness values put over there with the color. Okay, so that's what is the image data. Another version of image data itself is video. Many images coming in sequential pattern, right? So one image, next image, next image, next image, like that. In 1 second, you get 22 images. It looks like a video for human brain. That's all. Okay, so image actually contains even video for us. Then you have a text data that is related to whatever we write, maybe in handwriting, we type something, right, etc. So text data is that, right? Again, this can be further extended further for analysis of language, analysis of speech, etc. You have a lot of applications over there. When speech is given as input and you want to convert speech into the text, right? Again, the text data comes into picture, right? But you look at one very important aspect over here, that is usually text data needs to be converted into number, right? Can anybody try to guess why so? Is it true? If you say it is false, then we may not have to discuss further. But if it is true, right, I want to know why. Text corpus needs to be converted into number. How and why are the question. How we may not be able to answer now, but why definitely we will be able to answer. Anybody wants to try? So what do you think when I ask the machine to convert one language to other language? I give a word, right? See, there is a Google Translate, correct? You type a word in English, right? Next to that there is a translator, and it provides the answer in Kannada. Let's say, okay. Do you think it understands what you are typing so that it can directly convert into other language and can provide? If that is the case, then what is written here is wrong. Okay, text corpus you don't have to convert into number, right? So that's my question, right? What do you think? Anybody? Just tell what you think. That's all. You have studied microprocessor, microcontroller, something, right? Have you studied? Have you done any programming? Microprocessor programming, microcontroller programming? I guess yes, right? Try to link something to that. This question you try to link over there, and maybe that gives you a easier answer. Yeah, I want someone to answer. Otherwise, will not be able to move ahead. Right? Will it again get stuck over? Okay.
Sir, it may be because of character we can convert it into ASCII number like that. Then we can convert.
Okay. Okay. Yes, that's right. Uh, Good, Sanath. And we have answer from Vandana. It will be converted into machine level language, binary data 0 and 1. So that means, irrespective of, yes, Vandana, that's, I appreciate your answer. So you see, what gets stored in a computer is a number, right? Though I write A, it gets converted into number, then only computer processes that, right? So if you want a machine to process your input data, it has to be a number, right? Though we enter, right, numbers, though we enter text or any special character, whatever you write, it has to be converted into number before it gets stored in a computer, right? So yes, that's the answer. So now you have a solution here. Needs to be converted into number means what you understand, correct? Okay, right. Then this can be represented. That's what is the knowledge point. Last point you can see there: scalars, vectors, matrix, tensors, etc. Tensor is something actually used by the by Google to represent the numbers in what is called as it's in a format called tensor, right? Just think like as of now, you can think that it is uh, it's a similar to matrix. Okay, so tensors is something new maybe for you. Don't worry about that. Scalars, vector, matrix, etc. You know, so data can be represented in any of these formats, right? So that is what is the overall idea we need to understand now. Okay, so right, my next point is right the summary of the overall ML what we have. Okay, so let's look at this. This gives you a very big picture, very broad idea. It gives you the names of various algorithms that we are going to study. Okay, so that's why this is very important. So just remember this one slide, right? Because I'm going to bring this slide at the end when we finish everything, right? I'll bring this back once again. just to justify that, okay, initially I told that we are going to do this and we have completed that. Okay, so I'm going to come to this slide at a different stage, but just remember what does this represent. So the point is, this is the question you ask. I have a data set, right? Do you know the targets labels in your data set? In the sense, I know these are my inputs, this is my output. If you have that, if you know what is this, in the sense, I know I have data set, I want to know that I want machine to classify this as a cat, this as a dog. I know the labels. Those are the labels. If you know that, you move to the left side, saying that this is the S, you go to the supervised side of the machine learning. If you don't have, you have to go to unsupervised, because you don't know how many classes are there, right? So unsupervised, actually no classes are known to the user, right? Supervised classes are known to the user, right? Now you just check whether there are continuous variables or class. Continuous variables refers to the regression, whether I need to predict something. My next number is 3.555. My next number is minus 3.8666, like that. You need to guess that, means it is a continuous variable. If it is a continuous variable, you do what is called as a regression. In the old slide, we have come across this word regression. Now you see what are the various algorithms that are going to be used. Okay, so names are given here. Right now, I'm not going to touch that, right? So under the regression, right, these are the very famous algorithms. Okay, next, if you say my data set is not a continuous one, but it has a classes, in the sense classes like cat, dog, horse, multiple classes, etc. You see that if that is the case, these are the various machine learning algorithms, right, that are widely used. Okay, move to the other side. If at all your question, if at all your answer was no, saying that I don't have any idea about what is this data set, how many classes are there, right, etc. I don't know, means you will definitely move to the unsupervised learning category. In that, you have to see what option you have, because there is no yes or no type of question. Do you want to reduce the dimension? There are many columns are there. I want to reduce. I want machine to reduce that. Then that is actually called as a dimensionality reduction. These are the very famous dimensionality reduction algorithms. Okay. Then if your question is to find the patterns or clusters, how many groups are there in this data? You want to find out, the answer is clustering. These are the very famous algorithms. Okay, so you see this gives you a very big picture, right, about what are the various types of algorithms that we are going to look at, and what will be studied by in the upcoming session. Then there is what is called as an anomaly detection. Anomaly detection, in the sense there is something which doesn't look good for us. Something is wrong. What is that? How to explore that? Right? Again, you have no idea what it is. You want machine to decide that. So that will be done by what is called as anomaly detection, and these are the famous algorithms which will perform, right, what is called as anomaly detection. Okay, so very important slide. This slide is very important. Okay, so I want you to remember this slide, right? This a question comes, which one to be answered, which one I should select, right? This will help you out. All right. Okay, quickly, quiz number 3. Okay, just type your answers over there all together, right? If your answer is, say, clustering for the first one, clustering, comma, next answer is SVM, say SVM, comma, 3, like that. So type everything over there, all right? Okay, yes, so we can see that what are the supervised learning tasks, right? So out of them, right, if you go back and look at the supervised, right? So regression actually falls under the supervised case. So the answer to the first question is regression, right? Unsupervised learning task, right? You just have to go back and refer to this. And in the unsupervised, you can see that the clustering is the one. Other than that, everything falls under the classification, regression, SVM, etc. are on the other side, right? So clustering is the right answer. How many steps are there, right, in the workflow? The previous slide actually talks about that, and we know that there are 6 fundamental steps. Yes. Okay, very good. Now, okay, I'm going to talk about, so we have seen the 6 steps. Step number 1 is simply collect the data, right? So we are moving to the last part of the discussion for the day, right? In which I'm trying to give you, right, some hint about what are the tools of Python you need to know, right? So that you can uh, you can process further each of the step-by-step process. So first step is collection of data. Doesn't matter how you collect, you have to get the data. Normally data comes in the very raw format. There may be missing numbers, right? There may be unwanted numbers, right? There may be errors, error values. There may be many things which are irrelevant to the actual data, right? When you collect it through, say, some sensors or something like that. So that's the first step. I'm not going to that level, right? That is dependent on you. Most of the time, we may collect the data. For simplicity, we may collect the data directly from the internet. Okay, so that is step number 1. Step number 2 is understanding the data, getting the insight of the data, and cleaning the data. Right. So, right, what right we are supposed to do there? What are the tools you have to understand? You have to know what are the software skills you need to know. Anyway, Python is the very basic, what you call baseline, right? On that, you need to learn something more, such as pandas. Pandas is one very powerful tool, right? Which anyway, we are going to discuss a little bit of that, right? Maybe we may not get a lot of time, but definitely I'm going to give you the material so that you can use them as and when required. And right, I will actually highlight what are the very important aspects of pandas which you need to know before we start the programming part of the this particular uh, the whole mini project thing. Okay, so the pandas, and another one is SQL. That is also another tool, right, which actually has a lot of support for the machine learning algorithm. Okay, so these two are the very important one. In addition to that, it is good if you know how to handle the various databases, SQL queries, etc. If you know, it is good. But for the time being, for our intention, for our requirements, the database, knowing the database is not required. Okay, so pandas, SQL and preprocessing are very important for us. Okay, that is step number 2, right? So in case of a data merging, what all we do, I have written here. Okay, so handling the missing data, noisy data, detection of outliers and removing the outliers, etc. will do. Okay, if you are collecting the data from various sources, right? One temperature sensor from one company, another different temperature sensor from a completely different company, etc. You have to integrate the results, right? This gives you in a floating format. Another one gives you a numerical format, that is the integer type or something like that. You need to integrate them. You need to convert them into the same format, right? So that's what is integration. Then the transformation is the next step, right? What do you mean by transformation? You perform normalization, aggregation, standardization, etc. We'll touch them when we go there, but just remember these words. Okay, if the data is too much, right, too huge, right, you may have to go to removal of redundancy, organize the data in some fashion, etc. are needed. So for which, what are the tools used, you know now, right? So these are the tools which we have to use. All right, so remember that. Let's move further. What are the ML models, right? Actually, ML models are already discussed. Actually, they are present over here. You can see here, these are the various ML models written at the last thing, right? So it's actually coming once again, so I will not touch that. I'll skip that slide. Okay, just to save some time, I'll skip that. That's what is the ML model, right? So then we go to the last step, that is step number 4 to step number 6. You have a fine tuning, right? You have to present your things, right? You have to format, you have to do something more than. Then if you want to deploy, in the sense, model is selected, model is performing very good, means you can make an app and you can put it over cloud, or you can make it to collect the data in real time and provide a result or something like that. So those are the 4, 5, 5th and 6th step, right? So in our scenario, we may not touch 4, 5, 6 in pretty much detail. Our fundamental importance has to be given for this step number 3. Learning various types of machine learning models is our fundamental idea. Okay, so we give a lot of weightage to this stage, right, and the previous stages to this. Okay, collection of data, data munging and the ML model is what we will be able to touch in pretty much detail during this particular course. Okay, so these steps are also pretty much important, but right, we may not have sufficient time to touch them in very detail. Definitely we'll look into the various aspects of them, right, for sure. All right, so that brings to the end of the session. If you have any doubt, please feel free to ask.